Hello students, Mr. Sims here, and we are starting with our Module 5 booklet on probability and statistics. It's a very short module, having a challenge at the end of day 7. So it's a little bit of mix. The first couple of days will be probability, and then the rest will be statistics. So turning to page 2, day 1, using probability to make predictions. And that's really what probability is used for. If you think about everything that probability is used for, from the weather outside to going to a casino and or lottery tickets or anything like that. Today's lesson objective: I can use probability to predict outcomes. Okay, so this booklet's a little bit different than booklets we've had in the past, is that I've kind of snipped in pieces that we'll talk about. So just reading to getting the idea. So probability measures the chance of an event happening based on the number of possible outcomes. Okay, probability can be expressed as a fraction or a decimal from 0 to 1. Okay, a probability close to 0 means an event is unlikely, and a probability close to 1 means an event is very likely. Right? And then the probability of a half, or 0.5, means neither unlikely nor likely. Okay? We can also express probability as a percent, and I'll show you that when we get there. Okay? And there are two main types of probability that will be discussed. One is theoretical probability, and that's in theory. Okay, what's supposed to happen? It's not always what happens. Okay? The theoretical probability is the number of favorable outcomes over the number of possible outcomes. So like, for instance, let's suppose we are the most basic. We're flipping a coin. The probability that we get heads on the coin is 1 out of 2, because there is one side that says heads out of the 2 possible sides. That's the most basic. All right. So let's take a look. In this video, we'll go through examples number 1, example 2, and example 3. And then there'll be some problems that will work out of a separate booklet. So, example 1. Determine if this event is likely, unlikely, or neither. All right. So we'll go back. Josh is going to choose a random card from 13 cards. The cards are numbered 1 to 13. What is the probability that he chose a card with a number less than 5? So we're going to find the probability that he gets a card that is less than 5. Well, we have to think about, how can that happen? How many ways can you get a number less than 5? Well, if the cards are numbered 1 to 13, that means a 1, a 2, a 3, or a 4. Okay? 5 doesn't count because 5 is not less than 5. So there are 4 outcomes, 4 ways that you could get a card that's less than 5 out of the 13 total cards. So that would be the probability. Now sometimes, move this up so you can see. So 4 out of 13. So now, sometimes looking at fractions, you can't really tell that likelihood of, because remember what we're trying to do is it likely, unlikely, or neither? So one way to do this is if we take 4 and we just convert it to a fraction, 4 divided by 13, to a decimal, we get 0.308. Okay, I'll just round it. And this would equal, if you think FDP, fraction, decimal, 30.8%. So there's a 30.8% chance that you're going to draw a card that's less than 5. So now when we talk about the likelihood, and yesterday in Fast and Furious, or the other day in Fast and Furious, you have the lowest possible probability is a 0% chance. The highest probability is a 100% chance. Okay, so we call this impossible. Okay, and we call this a certain event. Okay, impossible means it won't happen. Certain. Okay, and then you've got your 50% in the middle, which is the same as 0.5 or 1/2. Move this down so you can see. All right, and I like to talk about percents. I like to talk about probability in percents, but there are times where you're going to have to be able to recognize it as a fraction and as a decimal. All right, so the closer you get to certainty, that's more likely. Okay, and the closer you get to 0 going the other way, becomes less likely. And in the middle is kind of not likely or unlikely. So a 30.8% is unlikely. Anything less than 50% is unlikely to occur. Okay? Anything more than 50% is likely to occur. All right. So that's just finding basic probability. Now, part of the objective, we'll fold it up here, top of the next page, example 2. Peter will roll in it. So what is a good prediction for the number of times it would land on a 5? Okay. Peter will roll a number cube labeled 1 through 6 a total of 90 times. What is a good prediction? Okay. So because probability is a percent, probability is the same thing as a percent, and a percent is a proportion. So when we make predictions, the easiest way to do this is just set up a proportion. So let's start probability. Start with the probability that this will land on a 5. Well, there's 1 5 on a cube numbered 1 through 6 out of 6 total outcomes. Okay, and now you set a proportion up where the 90 becomes the bottom part. So if we roll this thing 90 times, we would expect to get, okay, cross multiply divide, about 15 times. Okay? And that's really how you find how you make a prediction. Okay, moving on to example number 3. Now we'll talk about experimental probability. All right. Now, experimental probability is based on an experiment that's formed. So usually data is collected, and then you use that data to find probability. It's different than theoretical, but it's still the number of favorable outcomes over the total number of trials. All right, so let's look at example number 3. Based on the data, what is the probability the spinner will land on 2 on the next spin? All right, many conducted experiment with a spinner. The results are shown in the table. Okay, this is the number that it landed on. This is the number of times it landed. So probability based on the table, well, it landed on 2 7 times out of a total of, now we just add the columns up. 10 plus 7 plus 6 plus 8 plus 5 plus 6, and we get a total of 42. All right. So now what we'll do is 7 out of 42, we can also make that a decimal. So take 7 divided by 42, and we get about 0.16 repeating, which would be about 16.7% chance. So I know the question doesn't ask this, but this would be unlikely to happen. All right, so this is the end of the video. So you have a coached example on the next page, and then the practice pages will be out of a separate book, and those are written up on the board. So this is Mr. Sims signing off.